Hi, welcome to Redis Labs Head in the Corner series. I'm Brian Sambodin. I'm a developer advocate, and today we're going to be building something together. We're going to be working on Spring Data Redis, and we're going to be building a Spring Boot Redis-powered RESTful API backend. With me, Brian Sambodin.
Right in the corner.
All right, so let me explain what it is that we're building and why. I'm a full stack developer, and every time that I step away from the front-end development, a new JavaScript framework just pops up. And to be able to evaluate those, typically you have to have some sort of metrics. And what I've been using as of the last few years, it's this nifty little application project called tut-spring-data-redis-react-todomvc. And it provides a place to compare and contrast different JS, SPA frameworks, implements the same simple to-do application with every framework, and then you can kind of check the difference between the technical, design approaches between the different frameworks. Like for example, with React, you have React pure functions and hooks versus components. So for every framework, you can basically kind of see, even within a single framework, a lot of different variations. So this is what the to-do-MVC looks like. This is what our final product would look like. Ours is going to be built with React.js in the front end and Spring Boot and Redis on the back end. So I wanted to take a look at the React.MVC website so you can see what we're talking about and all of the different implementations available. You can see that we have all the way from Backbone, which I don't know who's still using Backbone, to the popular ones like Angular, React, and Vue. So, of course, one of the issues with this is that React.MVC, it's purely client-side. There's no persistence, no real database. Everything happens in the browser. So, of course, the server-side guys and gals got a little jealous, and they decided to create their own to-do project. So we have To Do Backend, which is a sister application to To-Do-MVC. And luckily for us, the specs of To Do Backend and To Do MVC match together fairly well. So like To Do MVC, it hasn't been implemented with a very large number of server-side services stacks, so you can go there and compare and contrast not only in Java, but in Python, Ruby, pretty much every language you can think of, there's an implementation of To-Do Backend. So let's take a quick look at the To-Do Backend homepage. And as you can see, the To-Do Backend homepage also looks like a NASCAR race. There's so many logos in here for pretty much every one of the framework and languages that has been implemented with. So just for Java, if you click on JVM, that's a filter, by the way. If you click on any of this this word tag, this folksonomy, you basically will get just the list of implementations in the Java language. There are a few older ones with Spring Boot, Vertex, Scala, a lot of Scala here, Kotlin. So you can see that there's a very large variety of examples to compare and contrast from. All right, so let's go back to my slides. Oh, by the way, the complete source code for this, it's available on the Redis developer GitHub page. We also have a brand new developer page, which is Redis developer, and you can find this at redis-developer.github.io, and there will be accompanying articles for most of the videos that you see from me. All right, one of the cool things that I like this project is To Do Backend. It's that it provides a runnable set of tests that they're JavaScript tests that will basically test your backend to compliance with the spec that they have set out. And the spec basically covers pretty much all the CRUD operations that you would expect in a RESTful API implementation. But it also covers things like course headers and other simple things that you are to expect from a RESTful API. I've included this as a Git submodule in the repository. So if you pull down, if you clone the repository, recursing for submodules, you would basically get this js-spec folder that contains an index.html file, which will basically execute the tests on your behalf. So I'm going to go ahead and basically open those tests. First, let me show you what the tests look like on my editor. So as you can see, I have this file specs.js, and it's a very simple specification to test our API, and it tests all the CRUD methods from the API, but it also would test things like the content of the JSON and whether we're returning the correct course headers. All right, with that out of the way, let's actually run it so we can see and have a baseline to what we're going to be expecting. All right, so now let me switch to Safari. So in Safari, you notice that I've loaded that index.html file. And then to run our tests, I'm going to put the location where our tests will be running. They're not there yet. So it would be at a localhost port 8080. And the specification requires that you use the to-dos namespace for this. So now I'm going to run the tests. And as you can see, the tests fail. The first one, it's kind of a prerequisites test that tests for the course headers being set up, and it just does the basic get at the root, which should, in a normal API, return all of our to-dos. And then it tests all the different methods, HTTP methods, like post, delete, etc., etc. Okay, so what are we going to do next? We need a plan. And the plan is actually fairly simple. If I were to be building this from a UI set of specifications, I would start with the UI and basically peel the layers of the onions of testing from the outside towards the inside. But since we have two well-defined specifications, we're going to start with the server side and craft those endpoints. And once we have that in place, we're going to build our React.js. All right, so here's the plan. We're going to install the Redis server. Then we're going to play with the CLI to get familiar with some of the data structures that we're going to be working with later today. Then we're going to get our skeleton Spring Boot app up and running. And then we're going to use test-driven development to flesh out the API. The main project we're going to be using, again, it's Spring-Data-Redis, which is going to provide the connectivity in the abstractions to Redis that we need from Java. And once we have that in place, we're going to switch to the second part of this tutorial, and we will build a modern React.js application embedded in our Spring Boot application. So there are many ways to get a Redis instance up and running. Nowadays, we work with so many systems that unless you're writing your own Redis modules, I would recommend that you either use a Docker image or you use a Redis Cloud Essentials account. Redis Cloud Essentials has a free tier for life, so those two are very good choices. In our case today, we're going to be using a Docker image. So Let's download, install, and launch Redis using the included Docker Compose file. If you're not familiar with Docker Compose, very simply explained, it's a file that basically gives you a recipe of how to build a Docker image. And in our case, our Docker image simply has Redis, but it makes it very easy to launch and provide developers with an environment that matches the application that you're building. So I'm getting into the habit of putting a Docker Compose file in each one of my applications. All right, so we're going to switch to a terminal right now. And in that terminal, I'm going to type, let me show you what the contents are. This is our project. Right now, you can see that there's a Docker Compose YAML file. If I cat that file, you could see that it's a very simple Docker Compose file that provides a Redis Alpine image running on the default Redis ports, which are 6379, putting the data in the folder that's local to the application called data. That folder, it's it's also in the git ignore, so it won't be saved to the repository. Also, I am starting Redis in append-only mode, which means that we're basically not only using Redis as the fastest in-memory database, but it's also a persistent database. All right, so let me go ahead and do a Docker Compose up. So we're going to do Docker Compose up. And that will launch our Docker image. So notice that it's saying it's creating the Docker image, and it normally uses the name of the folder that the Docker image is on. So I have a pretty long wordy name for our project, and that is what was used to create the Docker image name. So let me show you something, that in the container. So now that we have Redis up and running, first let me show you what that looks like on the Docker desktop here. Notice that now we have this nice tut-spring-data-redis-react-todomvc, that's a mouthful, Docker container running. So now that we have Redis up and running, let's use the Redis CLI to verify our installation. So switching to the terminal, I'm going to type Redis CLI. And by default, Redis CLI will try to connect to the local host and using the default port 6379. So one of the things that we can do to know if the server is running, it's to ping it. In Redis, it's responding with pong. You can also pass a string to ping. What, no polo? All right, so we know that the Redis service is running, but we're going to use the CLI also to do a quick exploration at some of the Redis data structures that are going to be important for us today. And I wanted you to have a little bit of interaction with Redis via the CLI with these data structures, because Spring Data Redis is going to abstract so much of it that I feel that if you haven't worked with Redis before, it's all basically magic. So what I want you to be able to do is have a peek under the covers of how those Redis data structures that we're going to be using today work. So the two main data structures that we're going to be dealing with today are hashes and sets, and of course Redis keys, which are basically the way to access everything and anything in Redis. All right, so I'm going to switch back to the terminal right now, and we're going to play around with the Redis server using the CLI. So one of the commands that it's really good for development and debugging purposes, it's the keys command. Keys.star will basically give you a listing of all the keys under your database. Right now, I have none. This is an empty array. Beware though, this is a good command for debugging and development time, but it blocks until complete. In Redis, it's a NoSQL database that it's usually used to store large quantities of data, which means large quantities of keys. Therefore, this command can actually block and grind Redis to a halt because it blocks until complete. So it's a bad idea in production. There's a similar command called scan that will basically kind of paginate through your result set that it's much more suitable for production environments. All right, so we have, let's talk about keys. In Redis has string keys. They're actually binary keys. So they could be pretty much anything. They can be up to 512 megabytes in size. Redis has a single flat key space. There's no automatic key spacing. Basically, you are in charge of your own key spacing. In our case, Spring-Data-Redis will basically be in charge of the key space. One of the typical patterns is to use a colon to separate identifiers in a key from less restrictive to more restrictive. So for example, we could create a set. Let's create a value in Redis, and it's going to be, let's go with music. So it's going to be band, Beatles, instrument, drums, and we're going to set that key to the value Ringo. And I can also now get that key back using the get command. Yay! All right, so notice that the column pattern, basically, that's very typical in the Redis community, and a lot of the frameworks will actually do the same. For example, Spring-Data-Redis is going to use the class name and the primary key of an object to basically glue them together to create a primary key. So now that we have some keys in our system, notice that if we do the key star command, we're going to get a set of keys. Let's say that we add another key. Let's add a instrument. Let's see. Let's add a bass, and that would be Paul. And now I can do something like keys, band, Beatles, instrument, and I can do a star here. And now you can see that we have a pattern matching abilities in the keys command. All right, so that's all we need to know about keys right now. Now, the next thing I want to talk about is sets. So in Redis, a set is an unordered collection of strings with no duplicates. So sets are pretty commonly used for deduplication. Most of the operations have a big O of 1, and it provides a lot of set operations that are very useful when you're dealing with domain objects, for example. So you can do intersections, difference, unions, joins. So let's go ahead, and I have a little bit of data prepared here, so you don't have to see me typing like a slowpo. So in here, I have a sadd command. So that will be set add. I'm going to add under the key band Beatles member. So that will be the key that represents our set. And I'm going to add 4 strings to that set: Ringo, Paul, George, and John. All right, and notice that it returns the number of items that were inserted into that set. So to get all the members of the set back, I can use the set members or S members. And you can see that it returns John, Paul, George, and Ringo. To count how many items are in a set, we use the cardinality command, and that will be scard. So I use scard in the key of our set, and I get the value 4 again. And you can test for set membership, for example. I can check if I am in the set of Beatles, and I am not. 0, it's false. 1, it's true. But if we do the same thing with Paul, you can see that we get a 1 back. All right. So moving on to hashes. Now, a hash or a map, it has a number of named fields. It's schema-free completely. So think about JSON in hashes in Redis are a pretty good complement. Hashes are very memory efficient, and like I said before, they're made out of strings only. So here I'm going to use the H set. Now you can see the pattern that each of the Redis commands basically starts with the letter of the data type that we're working with. So in this case, I'm using the hset command. The key would be bands, Beatles, album, revolver, duration, and I'm adding the name value pairs of the songs and their duration. So I have Taxman at 241, Eleanor Rigby at 207, Yellow Submarine at 241. So we have, again, the command returns how many items were inserted into that hash. And we can now get individual elements of our hash. So for example, I can get the duration of the song Eleanor Rigby, and I get the string 207 back. You can also get all the members of a hash, of a set, of a hash, sorry. And I can also test for existence. So for example, I can say hexist, and on the duration hash, I want to see if the taxman field exists, and I get a yes. But if we pass, let's say, something by the stones, I'm going to get a false. So with many of these object-to-data store technologies, we do give up a fair amount of control about what happens against a database in the name of consistency and convenience. I'm a big believer in the trust but verify mantra, so that we can see what Spring Data Redis is doing and to gain some understanding of how domain objects are mapped to Redis. We will watch what happens under the covers by monitoring the interactions with Redis via the monitor command. So let's switch back to the terminal, and I'm going to open another tab, and I'm going to type Redis CLI and space monitor. And notice that we just get an OK back. And basically, this is pretty much a tail-f against the commands that happen in Redis. So here, let me bring up one of the commands that we ran before. So I'm running that hexist, and if I switch back to the Redis CLI, you can see now that we get basically a timestamp and the command that was executed and the arguments passed to that command. So here, let me do another one in here. For example, we can do our keys star, and as you can see, we get that feedback logged into our Redis CLI monitor instance. Hey, thank you so much for watching. Join me for part 2 of this series when we will get our Spring Boot app off the ground and dive into Spring Data Redis. And give us a like by smashing that like button. And subscribe for more Redis, Spring, and general Java content.